lecture, the discussion section, just to know what to focus on. You'll also start mulling over the problems here and there, and it'll become a lot easier when you actually dive in and start coding. Let's move on to the lecture here. So we're going to continue and hopefully finish up our discussion on math this week. So we left off last lecture talking about additional arithmetic operators. Today we're going to move on to logical operators, but before we do that, I wanted to review this example from last time. Right? So many of you did pretty well in answering this. I'm going to give you another chance to answer the first question here. So what do you, forget about it. So you guys did pretty well answering this last time, but this was actually a little bit of a tricky question, right? Because we had multiple unary operations here, operations here. And I gave you a rule for our compiler, the compiler that we're using in this class. But it turns out that the actual answer might be different with another C compiler. So it isn't clearly defined in the programming language what should be done if there's multiple increment or decrement operators in a single line of code. So different compilers may take different solutions. So that's probably not the answer you want to hear. But really what you should do is avoid these types of expressions, avoid these double operator expressions, because they're not only confusing for you to understand when you look at your code, but if somebody was to take your code and compile it somewhere else, your code might not work in needs in the same way. So just avoid having multiple in a single line of code. Okay, so let's try one more example today along these lines. So if you guys want to click in and tell me what you think X is. More seconds. Okay, great. So most of you got that none of these are the solutions. So this one's actually tricky. So in this case, actually X would not get assigned to anything. If you put this line of code into your program, the compiler would split this back out at you. Turns out the compiler errors are pretty useful. It says L value required as incremental operand. What does that mean? Well, it turns out that you can't have an expression over here, right? It has no idea how to apply a plus plus to y plus 5 because that's not a variable. So this would not compile. So let's move on to talking about logical operations. So what are logical operators? These are operators such as not, and or. If I could get a show of hands, how many of you have seen these types of operators before? Majority of you. So the notation in C for these different operators is as such. An and is just ampersand, pretty easy to remember. The and symbol twice. Or is this key, which is above the return key. So to hit shift and the key above return, you'll get this straight line. And the not is just an exclamation point. So what does each of these operators do? They do what we expect from logic classes that you may have taken before, or lectures you've seen on logic, the table is pretty straightforward. So if we have two expressions, and here we list out every possibility for true and false for these two expressions, we can go through and look at what each one of these operators would return. So if we have expression 1 and expression 2, it's only true if both expression 1 and expression 2 evaluate to true. Otherwise, it would be false. Similarly, with the OR operator, we can fill in this table. And with the OR operator, we have a true unless both expression 1 and expression 2 are false. And the not of expression 1 is just the inverse, right? A false becomes a true, a true becomes a false. And you can combine multiple operators to create more complex expressions. So let's take a look at a few examples of this. So again, I put the table up here just for reference. And let's combine operators. If you have your clickers ready, I'm going to run through some examples. So it turns out when you combine operators, the first rule that you apply is you generally evaluate from left to right. And so here I'm giving you an expression, and I'd like to know what this evaluates to. Is it true or false? Okay, good. This one should be pretty straightforward. But the way it would get evaluated, just to go through the steps, is we evaluate the first and then take the value of this expression and apply it to the second and, right? And so the first one would evaluate to false, and then we have false and true, which is false. So the next rule is that we evaluate ands before ors, regardless of where they appear, left or right. So, any guesses as to what this will evaluate to? Take a minute and talk to each other. So we're going to evaluate the and first, right? I'm just putting in these parentheses as a handy guide. And so this and would evaluate to false. And then we're left with the or. And since there's a true, the whole expression is evaluated to true.
So unless you specify which one is true or false, it's default that the one on the left is chosen with true and before false.
Sorry, for which operators?
For that operator,
For the
so it's evaluated from left to right.
Yep.
So unless you specify if statement, it's automatically read as the left portion, so it's like true or false.
So you're saying if there's an if in front of this?
No, if you don't specify, so it's automatic that it reads the left portion of the list.
Yeah, so if there's no parentheses and we only have one type of operator, it's going to go from left to right.
Okay.
But then the next rule, right, says that and before or. So the ands would get evaluated. So that's why we didn't go left to right here. And then obviously we can use parentheses as modifiers. So if you guys want to just go through this one, please. Okay, good. I see that. You guys see that first expression is going to evaluate true, and now we're left with an and between the true and a false, so we'll get a false. We also apply unary operators before and. So the unary operator has the highest precedence. Let's see an example of that. Give this a try. Okay, great. I think you guys are doing pretty well with this one. So yeah, we're going to evaluate the not first. So the not will go to true. So now we have true, or, true, and false. Next in the order of operation is the and. And so the and will go to false. And then, so it'll look like this. And so we'll end up with a true for the overall expression. So the evaluation actually stops when the value is determined. So this is actually.
When would you ever use not false?
So eventually we'll be replacing these with variables.
Oh, okay.
Right.
Well,
so if you
just
have,
like not false by itself, would you ever use that?
no, probably not,
Right.
unless you wanted to write code that's purposefully confusing.
Okay.
Yeah. So generally you wouldn't put not in a constant. You might as well just flip it. So this point about evaluation stops when the value is determined. What that means is we might not need to go through every operation to know what the answer will be. So for example, if we had true or false, we wouldn't need to get to that last false to know that the whole statement is true. So C can stop short, right? It can save compilation. We'll see an example. So here we have true or, and then another expression in the parentheses. Well, we didn't need to actually evaluate the second portion to know that this whole expression is going to be true. So it turns out that any logic statement can be written in terms of and, or, and not. So this is a complete set of operators for doing logical calculations, logical calculations. So when you're using these logical operators, obviously you have these true-false values. And there's a new data type that's called the Boolean that we'll introduce. So the Boolean type is specified by an underscore BOOL. And this is a numeric variable that can only take on the values 0 and 1. Turns out 0 is assigned to false, and 1 is assigned to true. So what does this look like in code? So we can define two Boolean variables, A and B, and we can initialize their values. And then similarly, we can print them out. And we can print them out using an integer format, which are numbers. So we have the percent Ds. It turns out that there's a new library that you can include that will improve the formatting of your Boolean variables in your code. It'll make it a little easier to read. And so we haven't really talked about libraries, but beginning of your program, you've only been including the standard I/O library. If you include this standard bool library, it'll give you a few new options. So what happens is you can now define bool variables with a prettier name, right? To look closer to the other data types that you've been using. You can use new keywords. So you can use the keyword false, which is equal to 0, and the keyword true, that's equal to 1, right in your code. But again, to do that, you have to include this library. If you don't include this library, the compiler will spit out an error because it won't know what these keywords mean.
So before, if you didn't put in that that library header file, would you need to put int and then underscore bool or no?
No, you can actually just define it. So you can just define it as underscore bool.
So it just assumes it's an int. Is that
It's not an int, it's a bool type, but
okay.
it's a numeric type. It's a numeric
Okay.
integer type. So a lot of the same rules for dealing with ints and longs, right?
Oh,
Now
right.
you have another type that's even simpler, a bool that can only be 0 and 1.
Okay.
Also, can't take true can't take other values other than 1.
We'll get to that in a slide.
If you're going to put that SD bool in your library, is that include? Do you have to include the SD? Okay.
Yeah. So yeah, exactly. So you just added additional line, and so now you're including both of these libraries. And you can make your code a little prettier. Bool. Now this is equivalent to this line. Like these are identical. But this new keyword doesn't change the underlying type. Right? It's still a numeric type. It still has the same underlying data representation in memory. And so you can use the same printf command, right, with the same format percentage. So it turns out that even though this is just a 1-bit number, it still occupies, a bool type still occupies 1 byte of memory. And the reason for that has to do with the way modern processors are designed. We won't go into that in detail, but just so you know, we're actually still wasting quite a bit of memory. Right? We only need 1 bit to represent Boolean So the question that was just asked is can we have additional values that are interpreted as true and false? So any numeric type has a logical value. Right? So if you were to put a double into a logical operator, there's an interpretation as to what that variable should mean, is it true or false. And that interpretation is very simple. So for every number type, when that number is set to 0, it means false. And when that number is non-zero, it means true. And this ends up being very useful in conditional statements, such as if statements, which we'll talk about a little bit at the end of this lecture, but we'll really get into next week. So let's see an example of this. So here we've defined a number of numeric variables, and we want to know what the expressions would evaluate so as logical values. So if we have a variable a, obviously it gets interpreted as 3, because we've set it to 3. Do you mind turning that up, please? Thank you. So if you have your clickers out, if you could just tell me what the logical value of this would be. Okay, good. You got it. It's true, right? Because 3 is obviously non-zero. So if we have a plus b, that'll evaluate 0, and obviously the logical value will be false. A plus equals b, that also evaluates to 0, right? And that will be false. A equals 2 times C, which is 2.0. And if you guys want to click in and let me know what you think the logical value is. And see, there's still a little bit of confusion about this, right? 2 is obviously a non-zero number, so this is going to get evaluated to true. B plus 3 times C is 0, so it'll get interpreted as false. Right? So even though this is 0.0, it's actually 0, so interpreted as false. So it doesn't matter what data type you have, they'll all value false. Similarly, if you have a car, and so if you had a car that is a 0, right, the underlying numeric representation is a 0, it'll also appear as false. And C, any guesses as to what this would evaluate to numerically? So it'd be true, and so what happens is it will have the numeric assignment 1, which obviously is true. Is this pretty clear?
Is it because they're both non-zero?
What's that?
Is it because they're both non-zero?
Yeah, so since they're both non-zero, their logical values, right, are both true. So you have true and true, which is true for numerically 1. Right? If this expression evaluated to false, then the numeric value would be 0. Right. So let's talk a little bit about relational operators. So these are operators for testing equality, for example. So there's 2 operators that allow you to do that. So equals will return a true if both variables or expressions on either side of the equal equals are equal. The second one is a not equal, so it'll only return true if the 2 expressions are different. And then there's 4 operators for testing relations, such as less than and greater than. Less than or equal to, greater than or equal to. And so the value of these expressions with the operator will be true if the condition holds, and false, obviously, if the condition doesn't hold. So let's look at a few examples. So again, we have a set of predefined variables, A, B, and C. And our first expression here is B equals C. If you guys could click in A if you think this is true, and a B if you think this is false. Okay, this one's pretty obvious. So the numeric value here is 3, which will evaluate the logical value of 3. Right? So you might be confused by this 3, right? Notice this is a single equals. Right? So this was a little bit of a trick. This is an assignment, right? And every assignment also has a numeric value. So you're setting B equal to C, which is 3. And then the overall value of that expression is going to be a 3, which evaluates the truth. So similarly, we have C equals A. Just click in. Good. Most of you see that this is false because C will get set to 0 and will be interpreted as false. Now if we have A equals B, great. So most of you clicked in false, right? Because A is 0, B is 5, so they're not equal, obviously. So similarly, we have the expression with not equals. And so this should just be the reverse, right? So A is not equal to B, so this expression is going to be true with a numeric value of 1 and a logical value of true. B less than or equal to 8. And this one is true. This 5 is less than 8. Okay, so this one's a little more confusing. Any guesses as to how this would be interpreted?
False.
So if you want to click in with your initial guess. If you guys want to take a second and talk about this. Let's unpack this a little bit. So again, this is evaluated from left to right. This first less than operator would happen first, right? So this, what do you think this will evaluate to, right? Obviously, it'll evaluate to true. So then the numeric value takes on 1. And so now we have a 1 less than 3. So this example is pretty tricky. Let's try that again. Great, I think you guys got it. So again, we're evaluating from left to right. So 0 is less than 0.5, that's going to go true, which will evaluate to 1. And then we're left with 1 is less than 1, which is false. So let's say you actually wanted to check this, this mathematical relationship, right? Obviously, these formats don't work correctly. So the way to do it in C is to use an AND operator. Right? You're going to check these relationships separately. Check that A is less than B and B is less than C. So we would rewrite this, for example, as 0 is less than 4 and 4 is less than 3. So why do we have these logical expressions? Well, it turns out they're very useful for something called flow control in the program. What you'll see in the next set of lectures is a whole set of these types of control logic that you can put into your program. Today I'm just going to introduce you to one of them, which is the if statement, which takes on a very simple form. And then parentheses around an expression, and then a statement. So if the expression evaluates to true, then the statement is executed. If the expression evaluates to false, then the statement is actually skipped, and the next statement will be executed. So far when you've been programming, right, everything you've been doing is very linear. It's just a set of statements, and your program will always run in order. This if statement introduces multiple possibilities for the way your program could execute. Here are specifically 2 possibilities, right, if you have a single if statement, which is the program runs, we hit this expression. The expression could include variables that were input by the user, the values are input by the user. So based on the user input, this expression could evaluate to true or to false. And based on that, this statement would either be run if it's true, or not run and skipped over, and we can go on to the next statement. So let's look at a few examples of this. So here, we have an if statement that's evaluating if x is less than 0, then set x equal to its negative, print it out. And so this program would actually take the absolute value of x, right? So if the user input a negative value, then we reverse it. We'd reverse the sign. But if it's a positive value, we just retain the sign. So it's an absolute value. So we could have written this line of code a little differently. We could have actually used the asterisk equal or the multiply equal operator, and this would have done the same thing. Right? Here's another example. If balance is less than 0, then we'll print out chapter 11. So basically, if this was a financial program and your financial balance is 0, then this is a little joke. Chapter 11 is bankruptcy. So you declare yourself bankruptcy. We can use this for user responses. So like, for example, if you had a yes/no question and the user responded yes, you can check for that and print out a statement accordingly. Oftentimes, you'll be using compound statements. So let's say if you run this if and you want multiple statements to be run if the if is true, you can define that very simply by using curly brackets. Right? So if there were no curly brackets, then only the first statement would be part of the if statement. Right? But if you use these curly brackets, it's saying if this expression is true, then run both of these commands. Otherwise, skip over both of them. Is that pretty clear? And it turned out there was an alternative to writing this particular statement, or sorry, expression, which is instead of doing n mod 4 not equal to 0, it turns out that this is always going to evaluate, right, to 0, which would be, sorry, if this evaluates to 0, this statement would be interpreted as false anyway, right? So we didn't actually need to check if it was equal to 0. Does that make sense? Because if this mod evaluates to any non-zero value, then this expression will be true, and the if statement will be wrong. So let's see an example of using an if statement and these logical operations and relational operators in a program. So here's a program that is checking a few different variables and deciding on what to do. So let's say if your age is less than or equal to 90, and your GPA is greater than 3.4, or your income is greater than or equal to, it's quite a bit, way more than what I make, then you should plan for that. That's probably a catch right there. Somebody who's either really smart and have a lot of potential, or they're making a lot of money and they're not too old. So unlike arithmetic, the value is often decided from only part of the expression, right? So as I mentioned earlier, evaluation stops when the logical value can be determined. So with this particular statement, if the age is less than 90, is greater than 90, then these other things don't need to be checked, right? Because regardless of what the GPA or the income is, you're probably not interested in marrying that person. Everyone's got that. Similarly, if the age is less than or equal to 90 and the GPA is greater than 3.5, the income doesn't need to be checked, right? Because regardless of what this income value is, the whole expression would always evaluate to true. And this is just C's way, the compiler's way of being more efficient, right? Why even look at this if it doesn't matter? So let's look at another example. So So it turns out that this order of operations can be pretty useful. It can avoid certain types of errors. So if we have this if statement where we're looking at a divided by the value of a divided by b and seeing if it's greater than 1, what happens if b is equal to 0, right? If b is equal to 0, and these are integer types, we're going to have an error. A divide by 0. Turns out we can avoid that by using this order of operations wisely. So if we check to make sure that b is not equal to 0 before this expression, because if you take a look at this expression, if b is equal to 0, we know that this and is going to always be false, right? So then your program will never actually evaluate this expression, and will never hit the divide by 0 error. So it turns out that this early stopping is a really handy feature of the C programming language. So that's pretty much all I wanted to cover today. But before letting you go, we need to expand on this precedence and associativity table. Add in all of the expressions that we saw today. So it turns out that the not has high precedence, just like any other unary operation. We just added along with these plus pluses, minus minus, and the sign operations. And our relational and equality operators will happen after addition and subtraction. And then the ands and ors follow after that. So they're the lowest precedence. So this is pretty clear on how you would take a complex expression and go through this table and figure out what your composition is. So if there are no questions, that was all I wanted to cover for today. And we can move on to talking about next time. Any questions? So as I talked about with the if statement, right, all of the programs you've written so far have been very linear.